Is it visible?
Yeah. Uh, no. Yes, now it's fine. Fine. Yeah, it's fine.
Moving? Just a
Yes,
minute.
good. It's good. It's good. It's good. Yeah,
Okay.
it's moving.
Yeah. So shall I start?
Yeah, can be.
Yeah. So first of all, thank you so much for this opportunity, and I find this platform very helpful. The newly created group in the WhatsApp. So very useful information is shared on that platform, which is basically helping many newly medical physicists to learn the machine learning programs. So this PPT is not very much about the coding. It's just a basic information. What is machine learning? How we can implement? What is the basic steps in machine learning? So not a really long PPT. So we'll start with it. Myself, Sandeep Singh. I'm working as medical physicist in Rajiv Gandhi Cancer Hospital, New Delhi. So this first slide is a broad idea of machine learning. We all know about artificial intelligence, which is recently in very hyped topic due to many automation tasks. So artificial intelligence is just a science in which we make the machine think to act like human. And machine learning is a subset of artificial intelligence. And it also focuses on some specific task using programming without much of the human interference, we can say that. And deep learning is another subset of artificial intelligence in which we use neural networks. All the coding which we done, we use to make the machine to think like a human brain. All we know that there are many neurons in our brain. So we design the neural network to solve many problems, or like segmentation, like planning. Now you have recently heard about based planning. That is also a part of deep learning and machine learning. So what is machine learning? There are many different explanation definitions of machine learning. If we can say in the simple language, it is a learning process in which system improves its performance from the past experience. Like we just kept on feeding the data, we just kept on training the model. So based on what actually it is achieved in the previous iteration, it keep on increasing its performance for some specific task. If the another definition by some other author is, machine learning is just study of algorithm which improves the performance p. If we talk about in terms of variables, it improves the performance in at some improves the performance p at some task which we have assigned to the program t with experience e. So it is a well defined task using the three different variables. Okay. So why machine learning? Why we use machine learning? We develop system that can automatically adapt and customize to different tasks. Like we in Gmail, we are seeing that we have a spam filter. We can create different folders. So automatically the spam mails based on different keywords, different type of writing of the mail, it will the system automatically detect whether the mail is spam or it is from a genuine author. Second example is like data mining. You also know that there are different ways in which we can mine the Bitcoin mining is just like solving a very complex program or very complex task so that you just rewarded for that. So by the help of machine learning we can do that. But at the same time we require a very heavy computing GPUs systems to do all the work. Also, machine learning has the ability to mimic human, and it also not exactly we can say that it replace the human, but it means monotonous replace certain task which require a very little intelligence. Also we can develop some system that are too expensive to construct manually or required only a basic skill set or basic knowledge to perform that. So why machine learning is needed in this particular time. Why we are not able to develop, or we are not able to use the machine learning very previously? It is there, but the use of that particular thing is very limited. Why now? Because we have large amount of data. The basic step to perform any task or to perform any coding is we require the data. If we don't have the data, we can't train any program. Data. Second, we require space to store that data. After that, we require powerful GPUs, powerful systems, so that all the data can be processed at very limited amount of time, so that whatever task we want to perform, it will be performed in very fractions of second as compared to human being. Second, we require devices. Everyone and many of everyone has fully packed sensor. We have GPUs, we have phones which is permanently connected to internet, so we anything we can do on the cloud computing. And last is services, cloud computing, online storage, infrastructure, many applications. So in this era, we have all the things required to train, to implement, and to use the machine learning and artificial intelligence for any specific task. So when do we use machine learning? When human expertise, where human expertise is not exist, like navigation of Mars, we only send robots to navigate, to collect the data, to send the data, so that we can access the data, we can analyze that data on from the different part of the origin, a different part of any space, any point in space. Second example is where human can't explain or don't have the expertise, like speech recognition. Third is when model will be customized for different thing, like personalized medicine. And last one is the model based on human, where there is large amount of data, like genomics. In genomics, we have large amount of data. We have to pick which specific genes are correlating with each other. How can we analyze those genes? How can we analyze that data to perform specific tasks like DNA cutting and all those things? So this is the basic slide for different type of machine learning. First is supervised learning. So supervised learning consider is like it like you have two things. You have question and you have answer also. So first you provide both the things to a model. You provide question and answer to the model and ask the model to learn from those question and answer. So model will try to extract different features, different sentences, you can say that. So it will learn from many iteration. After learning, you will give a new problem to the system. So it will try to solve based on the knowledge acquired from that experience. So supervised learning is the example is when we want to say that, or we want to classify whether it is a dog or cat, whether emails are spam or not. We want to predict the market value of house based on the number of rooms, what is the square meter area of, and what is the neighborhood. So what we require in this, we require the training data and desired output for training the model. This is the first step. This is the first step. We require training data and the desired output to train the model. Okay. So there are two different subset of supervised learning. First is classification task and second is regression task. Classification is we have two different classes or as many number of classes as we want, but every class has a unique output like cat, dog, horse, or and number of animals we want to classify in different categories. But in regression problem, all the output is continuous, like price of a stock, temperature of a region. In this is the type of regression learning. So in regression learning, we have x1, x2 values up to xn, and we want a function fx to predict y based on given x. But the value of y is a regression value. There is a continuous value of y, and we want to predict or as close as actual based on our trained model without any human interference. And second is the classification, like cat or dog. Same is the whether there is tumor or not, whether a tumor is benign or malignant. So based on that particular data, we can predict whether the tumor, whether the system, whether the CT has tumor or not, and what is the type of tumor also. So till then, it is the supervised learning. And second type is unsupervised learning. So unsupervised learning is like you have something, you have some question, but for that you don't have any answer. So you will give that question to system. So system will automatically decide what is the type of question. So based on that question, it will give you some desired output, like grouping of images, detecting there is any bot activity or not, like anomaly detection, we can say that, and pattern recognition also. So this is the type of unsupervised learning in which in this we can see that this left side is we can see only one color. So we will give this problem to system, in which system based on their feature it will categorize these dots in different colors. This is a type of unsupervised learning. This is the second example. There is only one color in the question phase. We give this to the machine learning model. So uh, based on the relationship between these points, what is the size of these points, what is the distance between these points. So based on all the different information, it can classify these different based on those information, it can classify those same color into different colors. This is also a type of unsupervised learning. Based on different genomics, we can categorize one gene from different, and we can individualize those patterns from each other. This is also an example. We have two speakers, and there is also crowd, so we will get a mixed signal from from these two. So after applying any model, we can differentiate between the noise and the two speaker, whatever the pattern in the speaker is, we can differentiate between both. Third and last one is the reinforcement learning. It is like we are rewarding something, like what we want we are rewarding that, but what we don't want we are punishing that undesired one. So the famous example for that is the famous Mario game, in which if we keep on going without hitting anything, we will be rewarded for that, we can complete the level. But if we touch anything, that is it will kill the player. So this is a type of it will punish that particular player. This is a type of reinforcement learning. Till there is any question? If no, we'll drop a questionnaire in the chat section. Just complete that questionnaire. We have 5 minutes for that, and then we'll move forward. Dinesh, please drop the questionnaire.
I'm just dropping it. Second. Just dropped a Google form in the chat box. Can you please open it and answer the question? I'm just sharing my screen. Sandeep.
Yes, yes. Okay, okay.
Question is, which type of machine learning does not use labeled data? Wonderful, actually. Okay, we'll move on with the presentation. You can share your screen and move on.
Yes, yes. I'll share. So moving forward, what are the different steps to solve a machine learning problem? So there are basically 5 steps to solve any problem, whether it is machine learning, whether it is related to artificial intelligence, whether it is related to deep learning. So first step is collection of data. We require some amount of data based on the problem in hand. So we'll collect the data from different sources. Like if you want segmentation, you require CT and their corresponding structure set. If you want to do the planning, you require CT, RT dose, RT structure set. So for some number of cases, based on the model you want to deploy. So second step is data processing. Data collection is easy, but processing the data is very difficult. You have to see whether the data you have collected have the same dimension or not, whether there is any missing part, like there is any missing CT, missing RT structure set or RT dose in any of the patient. You have to check with the programming, is there any anomaly in the data. So data processing is the main part in which you take the unprocessed data, process it, and then give it to the machine learning program. If your data is not clean, machine learning program or deep learning program is not going to perform. Your accuracy or any parameter you are checking will be very low. The value of that parameter will be very low. Third step is feature engineering. You have collected the data, you have processed the data, but all the data is not useful for any program. So you have to extract main features of the that particular data. Like in the CT scan, you can means remove the background from whatever your region of interest. Third is the algorithm selection, and final is the making the prediction. We'll go one by one for that. So first, the data gathering. It depend upon human work like manual labeling for supervised learning, and it requires the domain knowledge or maybe expert. Like you require the art. If you require RT structure, you required expertise of oncologist. So nothing comes at free of cost. So it is saying that more the data, if you have more data, your algorithm perform good. In some algorithm needs large amount data like neural network. If you are going to do any segmentation, minimum amount of patient you require is like 450 to 500 to do any segmentation task. But the quantity and quality of data, if it is good, then only your model going to uh, means give good accuracy and all the different parameters whichever you are evaluating. Second is data processing. As I said, you have to see is there any wrong with the data, any outlier, any bad encoding in the data. So all these things we have to fix and we have to remove that particular uh, part of the data so that model is not going to confuse for that particular thing. Other is feature engineering. Engineering is like we are extracting our only a particular region of interest from all the data whichever we are we have collected in the data collection phase. So all those inputs, all those features will be given to the model in as a input to the model. more features we are extracting, more space we require to train the model. More space is required to train the model, more computational power we have to require, means more heavy GPUs are required to train that model. We have sorry, I've written a paper during my PhD thesis. It is on segmentation of tumor from MRI images. So I don't it is in 2021. I don't have any dedicated GPUs. So it requires almost 3 continuous day and night, to train the model for prediction. So number of images I have used, it's almost like 2000 patient MRI images with corresponding label, or we can say corresponding manually segmented tumor. So at that particular time, I don't have any dedicated GPUs, but also the GPUs are very costly. So you have to see for that also whether whatever task you are going to perform, or whatever problem you are going to perform or you are going to solve, whether you require any dedicated GPUs or any hardware which you require, because GPUs are very costly. And third step is algorithm selection and training. Based on what is your type of machine learning problem, whether it is supervised, unsupervised, or reinforcement, we have different algorithms. These are just some name. There are many, so many. We can also alter these algorithms and see when how they are going to perform. Okay. And last one is the prediction of the model. We predict, we train the model, then we predict using that model on the unseen data set. Whatever we are getting, we adjust based on that output. We adjust our prediction, and then again this step is continue until we get the desired accuracy or desired output, whatever we want. And this is called hyperparameter tuning. We'll talk about this in the future slides. So this is a complete uh, flow chart. How are we going to solve any machine learning program? We have labels and we have samples. We do the feature extraction, and these features are used as input to the machine learning model. This is the training phase, and then the prediction phase. Till this part, everything is same. After that, whatever we model we have trained, we use that model, and whatever and on the unseen data set, and get the label, whatever label, whatever problem we have, then we'll get the output of for that particular problem. So till now, machine learning is intelligent use of data to answer the question. There are three types of machine learning. There are three different machine learning type: supervised, unsupervised, and reinforcement learning. And there are 5 steps to every machine learning problem. First is data gathering, data processing, feature engineering, algorithm selection, and making the prediction. So there is quiz after this slide. Nish, please, can you post the quiz?
I'm just dropping the Google form.
Yeah.
Can you please? Yeah, I just dropped the Google form link. Please open it and answer the question. Like, the question is simple. Like, which one? The what mainly decides how accurate the machine learning model will be. Like, what is the exact parameters? That's what. So good to see. Yeah, fine. Sandeep, ji, we can move on.
Yes.
Yeah.
Just on shitting. So moving forward, till now we have learned about different types of machine learning. What is machine learning? So now we'll talk about what is the main principle to solve any problem. What is the main principle behind machine learning? What are different problem we are going to encounter while training a model and while solving any problem? So there is a principle called Occam's razor principle. So this principle says that it is a principle used in philosophy and problem solving examples. It suggests that the simplest explanation requires fewest assumptions. Example, if we have lost a key, we can assume that yes, we have robbed, maybe there is a ghost. But this principle says that the simple solution is that we have misplaced the key. And second example is uh, if there is any animal crop circles in farms, we assume that there is maybe there is aliens, maybe there is something else. But the simplest explanation is that there may be some deer or some buffalo which has trampled the crops. So whatever the simplest explanation you get for a task, it is using the fewest assumption, it will be correct. Also, it does not guarantee the truth of the simplest explanation, but it encourage minimizing unnecessary complication. The core message is don't multiply entities beyond necessity. Whatever required, just focus on that particular thing or particular phase. Don't assume anything more. But in machine learning, accuracy and simplicity are in conflict. So if you want accuracy, we have to we require more data, means more complexity. If we are going to simplicize things, maybe we are not get the parameters whatever we want to acquire in any machine learning tasks. So there is no free lunch theorem in machine learning. Means for any two learning algorithm, there may be or there are as just many situation in which one algorithm may be perform better than other and vice versa. But the parameters according to which parameter we are using. Means the measure of superiority we are using for that particular thing, for that particular machine learning model. So why we are developing new algorithm every day? So mostly if we talk about medical physics field, coders or physicists are mostly concerned with choosing the most appropriate algorithm for any problem in hand. Also it require knowledge, data distribution, probabilities, or the any physics underlying the phenomena. And the main challenge of any coder is to identify the correct problem and the correct classifier. That's why we are every day there are new neural network. You are maybe you read many papers. There is new development of new algorithm, new neural network. That's why we means up we are using many number of neural networks to solve the problem in our hand. So there is one many very common problem when we solving any machine learning problem, that is the curse of dimensionality. Means more is the dimension of the data, more the algorithm may be confused or maybe it can behave in very different way. One example, I'll show you the example first. This is the example. So this is a 2D projection of a 3D world. You have seen this on many social media platforms, but the actual picture is this. So we have this data, we have cropped the data, and we get this information. But if we feed this information to the machine learning algorithm, it is going to confuse what we actually want to do with it. And the second example of this, there is a cloud of points in 3D. which can be projected in different shape in 2D. We can see triangle, we can see circle, we can see square in different planes. If we see that, so this is the curse of dimensionality. So what we can say from this, learning from a high dimensional feature space, it requires enormous amount of, means very large amount of data, large amount of combination, different outputs, but with a fixed number of training iteration, the predictive power also reduces. So as a countermeasure, what for one example for that is, means you are doing a segmentation task. When you planning any patient or seeing the CT scan in your planning system, you can see that there is lot of black background around the CT scan. When you export that CT scan, that background is also exported, but you don't require that background. So when you feed, if you feed as it is to the machine learning program, first it require huge amount of space. Second, it require huge amount of GPU hardware power to train the model. And third, because your background is more as compared to your region of interest, machine learning or deep learning program is going to confuse what is their area of interest which we want to segment. So what we will do, we just crop that data. So we'll reduce the dimensionality. Suppose we you want to only do the segmentation, tumor segmentation in brain part. So just remove the other CT, other slices and the background slices, background also, so that your data is compressed. Only whatever information is required to do that segmentation, there is only that information present for the machine learning program. So one question, why machine learning matters in medical physics? Why we want to learn, why any medical physicist want to learn that machine learning program? First, if we talk about any clinical impact, it improves accuracy and consistency. In radiotherapy, if we say in radiotherapy, like auto segmentation of PTV, OAR, and also based on the machine learning, we can do automation planning. We can predict the dose. We can use that log files. We can use that shifts to predict whatever is going to happen in the future for others for same type of data. We can use in the imaging, we can reduce the noise in CT MRI using AI reconstruction. There is uh, artifact reduction programs in new CT scans. We can detect tumor in CT, PET, MRI. Second is it enhances patient safety like QA delivery, adaptive radiotherapy. So what is the main message? What we get from all this? If we train a machine learning program, there will be few error, less human interference, more reproducible treatment, and safer patient care. And if we talk about research and efficiency, it saves a lot of time in clinical workflow. Minimum time to do any segmentation, means like tumor and OR, the minimum time is required like 1.5 hours. But if you train a machine learning and deep learning model, it can do in seconds. Means the amount of time reduced from hours to minutes. Also in machine learning, in imaging QA, it can flag poor image quality and automatically we can predict TCP and TCP, and we can personalize treatment like patient specific dose adaptation, risk based planning strategies. All we can do using the machine learning platforms. Also, we can utilize the big data, different number of images, number of shift, number of daily QA log files to find any hidden pattern, what is how machine is behaving, and ultimately it leads to faster workflow, smarter clinical decision, and powerful research. So, and basic common tools and platform which we any medical physicists use is Python. Many use MATLAB also, but MATLAB is actually very expensive. and also require uh, very high computing power than required for Python. Different libraries, all these are NumPy, Panda, Matplotlib. All these are the libraries used to data handling, data cleaning, data visualization, and specific uh, libraries which we used for any segmentation task, planning task is TensorFlow and PyTorch. I can say PyTorch is more powerful if you want to learn any specific library for a specific task, learn this library. Instead of TensorFlow, go for PyTorch. PyTorch is more powerful, more research oriented, more it has more freedom to perform different tasks as compared to TensorFlow. TensorFlow is very easy, but PyTorch is a little bit difficult, but it has more power to solve any problem. In medical imaging and physics specific tools, PyDicom, Monai, OpenCV, these are the different libraries. And if we want to collaborate on different platform, we can use Jupyter Notebook, Google Collaboratory, GitHub is open community for different codes, and other cloud platforms are Google Cloud and AWS. And we can also do the clinical integration using AI plugins in TPS, PACS integrated AI tools, customized script for QA automations. Like scripting, you can use scripting in Eclipse TPS also for automatic planning. So, what will be the learning roadmap? Basic question for all medical physics students and new students. So, there are two paths. First path, which everyone tries to follow and trying to follow. Start with the foundational course. Learn basic Python, syntax, core libraries, and then they advance to specialized courses, deep learning, medical image analysis. They learn PyTorch and TensorFlow. And then they will try to identify a real clinical and research problem. They will introduce they'll develop a machine learning pipeline and program, optimize it, debug the code, then validate the result, like train the model, make the prediction, implement the solution. So this path is going to take minimum 1 year, almost 6 months for the first two steps. You have to complete minimum 3 to 4 courses. Each courses is like 450 hours, 300 hours. You have to complete those courses, and then you can do all these things. Yes, it is lengthy, but it is good. But if you want to do and think like a medical physicist, there is a second path. I called it the smart approach. So, and I follow this approach only. So, what I do, I just identify a real clinical or research problem to solve. Okay. You know that this is a problem. This is what the system is not able to do it. So, part by part, you will not get the complete code. If you get the complete code, then there is no need to no need to do anything for you. So you identify a problem, part by part you search for the code, but in this process, the main and major important step, you have to apply your physics knowledge or domain knowledge to tune the hyperparameter and improve performance. If you are not able to do it, it is just like copy pasting the code and doing, or you can say that extracting others work for you. But at the same time, because it is already written in some online platform, it is not going to helpful for you also. So there are only three steps: identify the problem, review the existing community for solution, tune the hyperparameters, train the model, and implement the result. Why path 2? It saves a significant amount of time. That time we can utilize in improving the model performance rather than writing the code from scratch. Because if you suppose you are writing a code for unit model, we know that unit model is code for unit model is available online openly available. So if you are going to write that, you are just wasting your time in writing that code. Instead, you can take that unit code and you can think how you can improve that unit model, what parameters you can tune, how you can combine unit with other models so that your problem in hand has maximum accuracy. So main is choose this approach only if you can modify, understand, and enhance the core logic. Simply copy pasting is neither ethical nor productive. Okay. So what are the common myth? Machine learning can replace medical physics? No, just it can support decision making. No AI or machine learning can replace any human being. We are the one who are developing these programs. More data always guarantee better result. No, data quality matters. Yes, data quantity also matter, but quality is has more weightage than quantity. So complex model are always superior. No, this is also a myth. Simple models can perform better for some problems. We have paper for that also. We have compared different models for segmentation task, and simple model actually perform better in that particular task. Machine learning can work like a magic black box magic. No, proper validation and understanding are required to train a model and implement that model. Once trained model can work forever. No, we have to train model, continuous monitor that, update that model. If also if we can say, if we think that if one model is trained in a particular region, like if I am training the model in for patient in Indian origin, it can work for different in US or in other countries. No, because the features, the anatomy of the patient, anatomy of a person is different based on the region. We have to train the model for that, but for that particular subset of patient also. So machine learning is a tool, not a shortcut. What are the common challenges? We The challenges, there is a limited high quality labeled clinical data. There is data, but labeled clinical data is very less. Data heterogeneity. We are using different scanner, TPS protocols. Every institute use different scanner, different protocol, till what length you are going to take scan. Overfitting is also a problem. Model perform well on training but fails when we are using it clinically or during the validation phase. Also trust, how are we going to build trust in clinical decision? Another problem is integration into existing clinical workflow, and also regulatory and ethical approvals also. So actually, real world machine learning is very harder than classroom machine learning. So what is the best practice? So start with a clear clinical research objective. Ensure that you have high quality and labeled, proper processed data. Use that data for training, validation, and testing. Avoid overfitting. Interpret models with physics understanding. And after that training, validation, and testing, use that model in clinical scenario and see if that model can really perform in that environment or not. Also document and reproduce the results. So finally, these are the some papers we have published for our studies. And that this is my team. We are continuously working. Everyone is moved from RGCI actually, but yes, till now we are in contact, and we are writing different papers on AI. So I thank you, my team, for this presentation for help. So thank you so much.
Thank you. Thank you, Sandeep ji.
Thank you so much.
Yeah. We'll have a last quiz. Just sharing the Google Form link.
Yes, yes.
And if any, is there any questions, please ask right now. In the meantime.
Hello.
Hello.
Yes.
Hello. Sir, I would like to ask that if any beginner is starting the process of machine learning, what generally GPUs are not accessible to everybody. So, what can a beginner like? What is the minimum specification he or she should get so that they can start the process? Because I think it will be very hardware dependent if uh, if you want to proceed without GPU.
So actually, it basically depend upon what type of problem you are going to solve. Like if you are using any CSV files, so it is not required any GPUs. With the simple i5 or Ryzen 5, you can solve that problem. You can use the coding. But if you want to do the segmentation or automated planning, then you require the GPU. Previously, when in 2021, when I have started using machine learning, at that particular phase, Google Collaboratory gives you unlimited time to train the program in in some amount for 1 month. But nowadays they also want to make money, so they give you 100 hours only for 1,000 rupees for 1 month. But when you are start training the program, that 100 hours will be utilized in 2 hours only, based on how complex your code is. So if you really want to do segmentation and this type of task, you have to get a GPUs, like minimum, which I personally figured out the minimum required space for GPU is like 128 GB to train this specific task. But like if you are, again I said, if you are using only CSV file, you can use on normal laptop also.
Thank you.
Okay. Question.
Sandeep ji, I have one question. You have
Yes.
said that there is a AI plugin for TPS, right?
Yes.
Is there any which AI for which planning system? How can we
Till
approach this?
now, for everything is I think available from for Eclipse only. We
Okay,
have three different platforms: Acure, Eclipse, and Monaco. In Monaco, I have not used anything. They have
mhm,
their own system for segmentation. I think its name is Abacus, or like this only. But
okay.
I don't know whether it is possible to do code in Monaco or not. But yes, in Eclipse, you can do the scripting and you can automate many things, like from planning to extracting the data for your use also. Reports like beam on time reports, how much time it has taken for a particular patient, and you can extract the DVH also. All these things you can do in Eclipse for till as of my knowledge till now. I don't know whether it is possible
Mhm.
in Monaco or not. I don't know.
Okay, fine. That is the SAP scripting we are talking about.
Yes, yes, yes.
Okay, fine. Fine. There is one question in chat box. So I said, I was asking that to Mr. Vignesh, how to define a proper selection criteria for the data collection.
So for data collection, like if you want to do the segmentation, machine learning program basically, or any program, you have to get the data, or means the size of the data should be same. Like if you are giving CTs to the model, so you can, as we know that the size of the CT scan is 512 by 512 into whatever the number of slices will be. So but the 512 by 512 is not required actually uh, for any for any program, because the majority is background only. So if you give the background and your region of main focused data to the program, so it require actually take so many memory that you require huge amount of GPUs to train the model. So whatever your region of interest, so crop that data. There is an option in Eclipse. Uh, in the selection in selection section you can uh, crop the slices, and then using programming you can cut the background from your region of interest, and based on that you can extract data and apply it to your input. Like if you want to do multi-organ segmentation from brain to till your neck, so this much amount of data you require, you have to crop accordingly, because whatever OER in the RT structure set you have, based on that you have to crop your CT scan also. And also whenever you are cropping the data, you have to very sure that the center of the CT scan and center of the RT structure set, that information is also fed to the program. Otherwise, you are not going to get any accuracy or any that uh, uh, parameter which is used for the evaluation of any program. Yeah.
Any more questions? Um, there's one more. Can you please? Yeah, please. Who's?
Sir, good evening, sir.
Hello, sir.
Actually, thank you for the nice presentation. I have a question regarding the validation. So you have said that proper validation regarding clinical metrics should be there for a
Mhm.
machine learning or predictive model that we have defined.
Mhm.
So, for example, if I am using a machine learning predictive model by
Mhm.
using the log files, I am predicting the
Mhm.
predictive failure of a MLC. Then
Mhm.
if I'm building a model, how should I validate
Mhm.
that, sir? For example, I'm asking that in validation metrics, what are the terms you use or how you proceed with that, sir?
Suppose MLC failure basically it is a problem how modulated your plan is. More the complexity of the plan, more is the possibility that it is going to there will be any MLC error or not. So validation basically means whatever model you have trained. Suppose you have trained the model on a set from your institute. Yes, maybe the model behave well, gives good accuracy for your institute data. But validation phase mean take the data from different institute for different protocols and see whether it behaves same way for your data and for different data also. One example I can give, which I have published a paper on OER segmentation. I have trained the model on my institution data. I have taken the data from my institute, trained that model. Then I have collected 10 patients from 7 institute, and then check whether that particular model behave in the same way on that data also or not. So the accuracy is almost comparable for different institute and my data also. That is a type of validation I'm saying about.
Yeah, okay, sir. Which means we should also state the uncertainties, the correlation, everything, right, sir?
Yes,
If we
yes,
are
yes,
going to validate.
yes,
Yeah, okay, sir. So and another, I have one more question. Like
yes.
you have said about the GPU and if we have the large set of data or the type of code which we use, the
Mm,
requirement of GPU comes into our play.
mm,
So if you have come across any cloud-based systems like a Google Colab
mm,
or anything you have used personally or which will be helpful for the persons who have a very less RAM and everything in their systems.
mm. So till now I have used Google Collaboratory only, but as I said previously, they give for 1,000 rupees. They give you 1 month. You can train and as many models as you want for 1 month. But now they have limited that the time period is 1 month only, but that they have limited the training period for 100 hours. But that 100 hours, how they are evaluating, that is a question. Means based on the complexity of the program, or we can say that the number of trainable parameters, based on the trainable parameters, that 100 hours may be like 1 hour for your model also. So but they have a means different plan also, that is more costlier, I think 5,000 or so for 1 month. In that plan you can train as many model as you can, but if you want to train on your local machine, you need to you need a GPU for segmentation and like this type of task. Whatever, I mean, whatever task includes CT scan, dose or structure set, you require GPUs. Without GPU, it is not possible to scan. Means whenever you run the code, simply it will give you error that memory is exhausted.
Okay, sir. Thank you, sir. Thank you for the information.
Okay.
Uh, Hello.
Hello.
Uh, First, myself Bhatt, CP Bhatt, and first I want to thank Dinesh ji. Starting a good initiative. So you people are working, doing good job. You started a group, and I think many activity are going on. And Dr. Sandeep, is very well presented, complex topic. Good flow. You presented it. So just one thing I want to ask, we are as a clinical physicist working in day to day in our clinic. Okay,
Mhm.
we
Okay.
are mostly busy with our clinical things, and that AI is here in our field. We have to have an understanding of AI. So just want to understand, and to all physicists, I just want to put a topic that what will be role of a physicist in an advanced center who is using AI and ML. Definitely in for contouring, for auto segmentation, AI will be there. In planning also, AI will be there. In QA, AI will be there. So what will be role of physicists? How to validate that AI tool? Okay. So how we can make ourselves ready for as a physicist, where we will have a more AI tools. What will be role of our in that case?
So basically, yes. Thank you, sir. Thank you for the appreciation. Thank you. So yes, we have AI tools for segmentation, for QA, for automated planning. Yes, but AI can also make mistakes. So role of a physicist is to check, is means it's like a second check for us. Whatever AI is doing, we have to check whether it is performing good or not. Like segmentation, if any segmentation is done by the AI, we have to, for some cases, yes, we have to cross validate uh, against the oncologist. Yes, what they are doing, what AI is doing. For QA also, same pattern we have to follow. Whatever AI is doing, we have to cross validate against the AI. In this way, we can, yes, we have to validate only. Otherwise, there will be disasters also, because completely relying on AI is also not good.
Like at the time of machine commissioning. Okay, so we are doing some QA. Okay, so in future, we'll have AI tool. Any AI tool that's also a part of medical device. Normally, in AI term, we are saying that's a medical device. Like for example, a TPS with the AI tool. So normally, in FTI term, they are saying that medical that tool, that AI tool as a device. Okay, so
Yes.
definitely we have to do commissioning of it. So at that time, what QA, that's a thought, just what QA will be there, how we will do commissioning of it. So in future might be, we will have those, we should have make ourselves ready for commissioning of it, QA of it. So that way we should have a basic understanding of AI and ML. Then only we can do, we can be make ourselves ready for doing commissioning and QA of it.
Yes, yes. Uh, Basically, sir,
Yes,
yeah, yeah. Please, Dinesh,
please,
continue.
Sandeep. I just want to have a thank you, sir, for Bhattji. Um, I just have a just thing is that what you are saying is that if we are having a full AI tool in our medical physics, is that still it's in development stage. The only AI tool so far in our market, which they are in commercially available, is that adaptive radiotherapy planning. Okay, so that is having a predefined set. like by using the same way the data they are using from the particular region or particular data set. So for ourselves, for the purpose you are asking, the commissioning and those things, we need to have a template in our own institution basis and to cross check and validate it in our centers. In that way, we can proceed with it, any kind of AI tool.
Yes.
Yes, please, Sandeep.
Yeah, I have the same answer also like that only. Yes, we have to validate. The only simplest answer for this question is we have to validate only. Whatever data, like uh, simple example is like in Accurate we have I have seen in the Accurate for Cyberknife they are saying that yes we have the golden data. You just need to cross check your machine against the golden data. Basically, we are validating that whatever data they have, whether the machine is performing according to that or only. So we have the standard data, we are validating the standard data and just using the data as our algorithm commissioning for that. So this is the simplest way we can say that yes, we have to validate only.
Any more questions? There's one last question from my side, Sandeep.
Yeah.
Just need to have a better understanding of the hyperparameter. Can
Mm.
you please give me some example in context of medical physics or the challenges you used in your studies? How you tweaked or tuned the hyperparameter with some examples.
Uh, in segmentation task, or I have used different models. Like as you know that we have the UNet model in which is introduced like 8 to 10 years back. But if we are going to UNet for now only, maybe it is not going to give good accuracy. So hyperparameter tuning is like I have implement assemble learning. I have trained different model and then merged the result of those model to give the desired output. Second example is you also heard about particles one optimization optimizer.
Mhm.
So but alone particle PSO is not going to give good results. So I've combined PSO and PCA to predict the whether there is tumor or not. If there is tumor, what type of tumor it is. So all these things is make the hyperparameter tuning. Like whatever you have to combine with it different thing, or you have to change something so that the desired parameter is enhanced.
That's all from my side. If there is any questions, then there are no questions, then we'll wind up this session. And really, thank you for your presentation. It's really wonderful. It
Yeah,
really
thank you so much.
helps most of the medical physicists.
Thank
Just
you. Thank you.
kickstart our curiosity and enthusiasm.
Thank you so much.
Okay. Thank you.
Okay. Bye. Thank you.
Well, thank you then. We'll closing the session as of now. If
Sure, sure.
any
Thank you.
questions, then we'll drop the WhatsApp.